Good morning or good afternoon, Honors Math 2. Welcome back from spring break. Today is Monday, March 30th. I hope you had a good break and I hope everybody's healthy in your family. I would much rather be together for this, but we'll do the best we can under these circumstances. We're going to do task 8.6 today. If you remember, before we left for break, we were talking about our second conic section, the parabola. I do have a little warm-up here if you want to get back in the swing of things, totally up to you. If you want to pause for a second and try this warm-up on some scratch paper or in your margin, I'm going to do it as well. Can you write the equation of a parabola with our new definition of distances with a focus of 5, -7 and a directrix of y equals 1? A parabola is the set of all points that are equidistant from both the focus and the directrix. If you can sketch a little picture and write that equation, I'm going to pause now. Okay, thanks for trying the warm-up. I get a parabola that opens upside down, directrix, focus, vertex is directly in between, equidistant from the focus and the directrix. The distance between those two was 8. That gives me a p-value of 4 to the vertex. My parabola opens upside down, and I get an equation of y equals negative, since it's opening downward, 4 times p, which is 4, is negative 1/16. X minus 5 squared minus 3. All right, thanks for trying the warm-up. Can you take a second and read this task as we turn it around today with our parabolas? All righty, I'm going to pause so you can read, and then we're going to find the equation of this parabola. Okay, so in this case, Annika rotated the focus and the directrix so that the directrix is vertical. So this is my directrix, now at x equals 0. This is my focus, if I can label it, at 2, 0. Please plot your vertex and then connect those equidistant points to form a sideways parabola. Okay, I labeled the important parts when we rotate that parabola, and I have a focus at 2, 0, that vertex at 1, 0, and I connect all of those points to form a right opening parabola. And now I'm going to use the definition of a parabola to find the equation of this right opening parabola. Remember, if I use this point x, y, that this distance d1 from that point to the focus has to equal this distance d2 from that point to the directrix. So I'm going to use the fact that d1 has to equal d2. d1, using the distance formula, is the distance between x, y, and 2, 0. Plug into the distance formula for d1. And d2 is the distance between that point and that vertical line. Take a minute. Okay, so now we're doing this. We're using the definition of a parabola to write the equation of this parabola. d1 is equal to d2. d1 is the distance between x, y, and the focus. I plugged into the distance formula. And d2 is the distance between that point x, y, and the directrix. X minus 0, which of course is just x. Using the definition, the set of all points equidistant from the focus and the directrix, I'm going to set d1 equal to d2. I get the square root of x minus 2 squared plus y squared is equal to d2, which is just x. I'm going to square both sides. X minus 2 squared plus y squared is equal to x squared. I'm going to use that trick from last week. I'm going to get those x squareds to cancel out in this case. If I square this, careful, x squared minus 4x plus 4 plus y squared is equal to x squared. And I'm close to the standard equation. My x squareds cancel out. Now I'm going to isolate the x. Negative 4x is equal to, move over the y squared, negative y squared, move over that 4, minus 4, divide through by negative 4. And I get this equation, x is equal to, what is that? 1/4 y squared plus 1. And that is the equation of Annika's right opening parabola. X is equal to 1/4 y squared plus 1. Please notice that the vertex of her parabola was 1, 0. See if you can find it in the equation. And what's the p-value? Please find the p-value from up above. That distance from the vertex to the focus, in this case, is p is equal to 1. And we're going to start to see the standard equation of a right opening parabola or left opening parabola is going to be x equals plus or minus 1 over 4p times, here's my y squared, y minus, careful here, k squared plus h. Alrighty, let's see. Keep that in. Oh, what I wanted to point out is this is right opening and the coefficient is positive. With a right opening parabola, that leading coefficient there is positive. Let me pause as we move on. Okay, thanks for working through a task with us. Please try some things on your own as we go. I'm going to ask you to list a couple of things here, but let's refresh our memory now on our two equations. Last week we saw this equation of a parabola, y equals plus or minus 1 over 4p x minus h squared plus k. Now Annika just got this equation of a parabola, x equals plus or minus 1 over 4p y minus k squared plus h when it opens left or right. Please take a moment and pause and answer that question if you would, just to kind of help yourself out. You could always Skype your friends and work through a task together if it's a little bit more social. Alrighty, I'm going to pause here while you answer question number 2, and then we're going to try question number 3. Okay, obviously you have things similar to me, but you could have some different things phrased differently also. I usually say that an up-down opening parabola is a y equals. That's what we're most used to. Now we saw a left-right opening parabola has an equation that's an x equals. Of course, the vertex is always hk. What you should notice is the h is always with the x. The k, the y coordinate of the vertex, is always with the y. So we just are a little careful of the placement of the h and k. Again, you may have listed some other things there. Can you take a moment, I'm going to pause as you pause, and try to write the equation of a parabola whose directrix is x equals 4 and focus is 0, 3. Let's give each other a chance to get started. Okay, here's my sketch. With a directrix of x equals 4, a focus at 0, 3, the vertex has to be right in between. That's 4 units. So the vertex is 2 units to the right of the focus. And my vertex ends up at 2, 3. Now this parabola opens to the left, and I see my p-value right here of 2. If my parabola opens to the left, it's going to be an x equals, but it's going to be a negative 1 over 4 times p, which was 2. My vertex was at 2, 3. Remember, it's y minus the y coordinate, which is 3, plus the x coordinate, which was 2. Let me clean up my equation, and x is equal to negative 1 over 8 y minus 3 squared plus 2 is the equation of my left opening parabola. Certainly we need a little bit more practice with that. It's a little awkward when those parabolas open left-right. It's not what we expect, and that's going to get to these two little questions down here as you start to notice. Alrighty, can you try that one more time with number 4? Okay, let's see how you did. Here I have a directrix at x equals negative 3, and I have a focus at negative 2, negative 5. I'm going to try to find the vertex. Notice this is a tight little parabola. There's only one unit between the directrix and the focus from negative 3 to negative 2, so my vertex is going to be right in between. This is only 1 unit, so my p-value is actually a half a unit. So p is 1/2, and my vertex is going to stay at negative 5 for the y-coordinate, but the x-coordinate is right in between negative 2 and negative 3, which is negative 2.5. I'm going to plug that into my equation of a parabola, and I get my p-value, which is 1/2. My y-coordinate of my vertex is negative 5, and my x-coordinate of my vertex is negative 2.5. or negative 5/2. I'm going to write the equation of that parabola as x equals, it opens to the right, so the leading coefficient is positive. This is my more standard parabola, opening to the right. Opening to the left is negative. Half of 4 is 2, so my coefficient becomes positive 1/2. Y plus 5 squared minus, I'm going to write that negative 2.5 is fine, or 5/2. And there is my equation of a right opening parabola. And see how you did. That was a good one for practice. Alrighty, can you take a second and answer question 5 and 6 on your own? Okay, you probably said something like this. How can you predict if a parabola will open left, right, up, or down? My up-down parabola is my y equals, and then it opens up if that coefficient is positive, down if that coefficient is negative. My left-right opening parabola is an x equals, opens to the right if that coefficient is positive, opens to the left if that coefficient is negative. Okay, for question number 6, how can you tell how wide or narrow a parabola is? You can probably remember from our work with parabolas that we look at the coefficient to see how wide or narrow a parabola is. Do you remember which of these would be wider? I know my sketches are not perfect, but which of these parabolas would be wider? This would be a wider coefficient. That smaller fraction would be a wider parabola than this parabola. How does that relate to the p value? For a wider parabola, how does that relate to the p value? I say the larger the p value, the wider the parabola will be. The larger the p value, the wider the parabola will be. And finally, for our up, down, left, right parabolas, can you answer question number 7? Please pause. Are all parabolas functions? You probably said no. Notice my parabola number 3, in 3 and 4, those left-right parabolas, do not pass the vertical line test. For many inputs, there is more than one output, and they fail the vertical line test. So are all parabolas functions? No. Which parabolas are functions? You probably said something to the effect up-down opening parabolas are functions. That's our typical y equals parabola. But left-right opening parabolas are not functions in the form x equals. The nice thing about our conic sections is it allows us to study shapes, equations that are not functions, like an important conic section that we see tomorrow as we move on to a new conic section tomorrow, our third conic section. Finally, are all parabolas similar? You probably said no. Some are wider, some are narrower, so they are different shapes. And the shape of the parabola, depending on that p value. Ladies and gents, thanks for watching and thanks for working through on your own as we go through things also. It helps you out a lot. Our assignment today is the 8-6 Ready, Set, Goes. That should be done today on Monday. Similar to last week, I will check in a few select problems on Friday. You'll submit a few pictures of your homework. So thanks for working through stuff with us. We move on to our third conic section tomorrow, so tune in tomorrow. Have a good afternoon.